Very warm welcome back, everyone. This is one of our last sessions through the series of coursework. Next week, you guys will be starting your project-related activities, but exciting week. And this week, we are going to do some important topics, which actually you will see a lot in the in real-world applications. So, without further ado, let me share my screen and before we look at the app that you see on the screen, I want you guys to understand the sorting in general in JavaScript or any language, right? Sorting is rearranging traditionally numbers, but not always numbers, but stuff like array of strings or any other details in an order. And what do I mean by that, right? So let's create an array. Let me put it this in this side so you guys can see why with the code, right? So let's say we had an array, right? And it holds some numbers. Let's say, let's start from 3, 2, 4, 6, 2, and then 5. So these numbers are right now arranged in an order which is there is no uniformity. There is no logic to this order. Uh, you can always rearrange them by sorting. So you can always say uh, my array and then simply keyword dot sort and not shift sort. And by default, it sorts in an ascending order. So lower number first and the higher number later. Same goes for the array of strings as well, where any string that starts with letter A will come first, then any string that comes with letter B will come after that. And if there is a tie between two strings, so let's say if there was an array like my string array, and if there was a tie between two strings, right? So let's say A, A, B, C, and there's another A, B, A, C. Let's put it that way. If there's a tie, then it looks at the second character. So how do we verify that? Before, yes, how do we verify that? So simply, okay, my array string dot sort again. So you see, actually I put it in sorted order, but let me redefine this. Or let's do one thing. And then you can provide a function a b, but the sort can be an empty argument, or you can provide your own implementation of how you want to sort. So it's better explained with my array of numbers. So right now, if you see my array sorting, put it as 1 to 6 in an ascending order. Let's check the current values of my array before we go anywhere. So now it's an ascending. Now we are able to actually change this order as well. All we have to do is we say first number, any argument will be referred to as the first number, and then you should have a return type. So b minus a uh, is a difference. So I want the number b to be bigger than a. And if you see it now, Our array is sorted descending. So the biggest number comes first and the smaller number comes the second. Now, the same thing can be applied to strings as well. So in the past, we have sort of dealt with fruits and all kinds of um, details. But now let's look at from the string perspective. Some of you might be familiar with this list of Pokemon that we used to build one of our previous projects. But what I have done here is I am calling an API. And how do we verify that? I am calling an API on when my component loads. So even before looking at the code, how do we verify? So if you go to your network tab in your debug console, you can see an API call being made to an external website or external endpoint of an API as we refer. The endpoint is Poke API. And from there, I'm grabbing the Pokemon species. And if you see the response of this, it gives me back all the details that I'm seeing here, Bulbasaur, Ivysaur, Venusaur. So all the names of different Pokemon that you see here, these are not hard-coded in um, our application. So now going to the code, let's look at the code. What the code denotes is we have a Pokemon list, which is an empty list first, and when the page loads, we are using useEffect hook with fetch Pokemon function, which uses JavaScript fetch to call the API. If the API has a data, we set the data as our Pokemon list. And once we have the Pokemon list, we are building a table, a simple table, where we have a serial number and a Pokemon name header. So if I go back to uh, the screen, we have a serial number header and a Pokemon name header. And now going back to the code, we loop over the Pokemon list that we got from the API above. On the line 13, the list that we got, we are looping it over and displaying all the Pokemons here. So stop me if any confusions till this point if, as to how this Pokemon list was displayed on the page, even though we did not put this Pokemon names anywhere in the code. If no questions, then I'm assuming everybody got it. Now we have this Pokemon list, and if you see, the name of the Pokemon have no particular order. So B is appearing first, then I, then V, then C is appearing. So there is no, and then on the line 9, B again is appearing. So there is no particular order that that is there. Well, uh, we can use the same logic that we used previously when we sorted our numbers and sort. So this is another array. If you see, this is an array of 20 items, 20 Pokemons, and we can use this array to reorder the items inside the array. A typical way to do that in tables in web applications, as well as if you guys have uh, played with Microsoft Excel, is you click on the table header. We can demonstrate similar functionality by clicking on this, and as soon as we click, the Pokemon list is sorted. Now, if you see, it's ascendingly sorted, and all the Bs are coming first. If there was a Pokemon starting with name A in this list, it would have come first. All the Bs are coming first, and even within B, there are some conflicts in the sense that there are three Bs, so it's picking based on the second character, like B drill and Blastoise. So E comes before L, so it's breaking that tie using the second character. If it cannot break a tie, it goes to the third character, just like in the case of a line 3 or line 4, but it is sorting. So let's see how it is sorting. So to do that, there is a simple on-click handler put in on the uh, on the Pokemon name header, and on click of that, we define the sort order as ascending or descending. So we remember if what is the previous sort order. If it's ascending, we sort it descending. Otherwise, we sort it as ascending. So this is simple. You can only have two types of sorting. So all we have to check is if previous sorting was ascending, then now we have to sort all it's descending. Otherwise, if previous sorting was descending, we have to sort it ascending. With that, uh, we are now implementing our sort function, and we are saying if it's an ascending sort, then this is your just like A minus B in a sorting. So put all the A's before B's. What this line 33 means is put all the A's before B's, and this line 35 means put all the B's before A. So we are saying if the sorting order is ascending, which we identify from line 28, then we are going to put all A's before B. Otherwise, we are going to put all B's before A. So here we did not have, when we first load the page, we do not have any kind of sorting. So when we click first time, we are saying put all the A's before B's. In our case, all the letters which come first in the alphabets, those names will be first. So here B drill is coming first, and the V drill is coming. Vartortle and Beedle are coming. Beedle are coming the very last, like Venusaur. We can sort again by clicking, and now the order will reverse because now the code flow will come here, and it'll say the sort order is already ascending sort order. So it will sort it by descending, and if it's descending, our code will skip line 32 to 34, and it will go on line 35, and it will put all the B's before A's. So all the letters that come in alphabets before at the later stages, they will be put on top. This is very similar to what we did here with our array. Let's redefine our array. So, so putting B's before A's is very similar to sorting in reverse, where here the number 6 is coming first. Instead of number 6, any Pokemon that would have started from number Z character Z would have come first, and then in that order, in the reverse order, it would come. And we can continue to toggle between this. So this is a very common problem that you will be working on when you deal with tables or you build your tables when you go to real world. Any questions on sorting and what A before B or B before A meant really in the string context? You guys put any questions in chat? Uh, if not, we can move forward. But again, you guys have any questions? You can ask now, or you can ask at the end of the session, or in our one-on-one session if you like to ask at that time. So you have all the options, okay? Another important thing that we need to learn is tables can contain a lot of data. Here we are showing 20 data, 20 rows of data. But if anybody has played Pokemon games, they would know there are a lot many Pokemons than just 20 Pokemons. And if you try to render all of them on your screen, it would be a bad user experience because then they would have to scroll too much. Like they'll have to continue to scroll longer and longer and longer to reach to the Pokemon they wanted to reach. Plus, the more data you put on your React components, the slower your React application becomes. So it is a standard best practice to use pagination along with any table kind of structures. What is pagination? Pagination is nothing but breaking your data into smaller sizes. So let's say you had 200 Pokemon. You break your data into 20 Pokemon with 10 groups. So 10 into 20 is 200. So now you break your Pokemon into that many groups and you display 20 at a time. So once users says, give me first 20, you display first 20. Then if the user says, give me next 20, you display 21 to 40. So enough of theory explanation. I'm going to keep this code. So this application that you will get, it has two app.jsx files because this is like, I did not want to sort of merge the sorting topic with the pagination for better explanation when you guys refer the code back. So uh, to run the other app.jsx, all you guys need to do is come here, comment this line out in main.jsx and import app from app2.jsx. Let me do something. That topic will come a little later in the class. So here, if you see, previously we were showing 20 Pokemon at a time. Now I have, but we actually had lot many Pokemons than 20 Pokemon. And how do I know that? Each API traditionally will tell you how many items it has. So this API that Poke API team built tells us that there are actually 1025 Pokemon into in their total database, and we are showing 10 at a time. So if you divide this number by 1025 divide by 10, you get 102.3, meaning if you round it up, 103 total groups or total 103 pages. So here we have broken down our application into total 103 pages. So this 103 number is not a random number, but actually a calculated number. And in the pagination, you will have this kind of calculated numbers. Uh, you might also see an option to change the number of Pokemon that you see on a page. And I highly recommend when you guys are done with this, once you pull this code to try to implement that. But here we are showing only 10 Pokemon at a time. And when user clicks on next, we display next 10 Pokemon. If you see the list is changing, and also we are telling user that this is the page number. Now internally, how are we doing it? First, look at the network calls. Uh, every time a user clicks on next button, we are calling the Poke API. And in the Poke API, we are passing additional parameter, which is a limit 10 and offset 30. What is limit? So limit is how many Pokemon we want to show here, and offset is what is the first Pokemon I want to see after the number. So I want to see the 31st Pokemon and I want to get the 10 Pokemon from the total 1025 Pokemons. So if I click on the next page, it'll make more sense. Now the limit stays 10 because we want to sort 10 at a time, but our offset becomes 40. That means I want to see Pokemon from 41 to 50. So how do I know that? Well, if we look at our code in app2.jsx, very similar code to previous one, we are doing a fetch of a Pokemon, but if I had to do a side-by-side compare with the previous, let's see if I can do a side-by-side. It's okay. We can look at here. If you see the line 13 in the previous call we had, and if I copy this line here, we see that we have a slightly modified API call that we are making. This was our previous from old app.js, or I say old app.js API call. We are simply calling the API. But here we are specifying two parameters while calling our API, limit and offset. So when we first load our application, let me refresh this, remove this. So when we first load our application, our limit is 10. Uh, Limit is always going to be 10, but offset is the current page number. So it's 0. So we pass two parameters, offsets and items per page or our limit, and we define the initial values of this value, um, items per page and our offset, and we calculate this calculated values we are able to pass it to the API and get only the subset of data. And then once the data receives, just like our previous code, we are setting the data. And additionally, we are setting an extra parameter, which is called total count. And we are leveraging that parameter, the total count parameter, to count the number of pages that are there in our application. And we are building this page. So this is something that is known as pagination, where you break the chunk of data into smaller buckets and display one bucket at a time. Pagination can be purely done on the React component or the user interface as well. But in most modern and real world applications, you will see the pagination is implemented using the UI as well as uh, APIs or server side call. And you will be working with a team of developers to come up with this approach and identify the limits and offsets. But this API that the code you will have allows any kinds of offsets and limits. Let's try 20. So you could say I want 20 items per page, and let's see if we get 20, and our page size becomes half. So it becomes just the half of it. So fail to fetch. Maybe the API went down because I'm calling it too many times. But that's okay. Those guys are. So the next thing that before I jump to the next topic, sorry, this is a little bit of a complex topic, and if you guys have any questions, stop me here and ask. Limit, offset, pagination. We introduce some important terminologies here that you guys will be dealing when you build the real applications and try to make them smooth and workable. You will need to understand pagination and the limits and the offsets. So any questions here? Remember, three things: pagination, limit, and offset.
And if we have different size of screen, iPad, for example, or laptop, can we dynamically define items per page and how it better to do? What is the approach?
So while it is technically possible, it is generally not recommended to change your page size just because the laptop screen size changes. Well, when you build an application which is like a web page or web application which is to be rendered in a mobile device as well as a desktop, right? In that case, you could have something like a smaller limit for mobile devices and bigger limits for desktop devices. But changing those limits and offsets changing those limits on the really on the fly while you resize your screen like this. Uh, let's say you make it smaller. Now this is like a smaller laptop. Uh, and if I do it like this, right, if I do it like this, it becomes a like a bigger screen laptop. This is not a good practice. You define a limit based on the device size to begin with, but dynamically changing would not be a recommended approach. Does that make sense?
Yes, it's great. Thank you.
No problem. You're welcome. So, turn on to see the news. Moving on to next topic. So, some of you might have remembered uh, when we built our fruits application, we were remembering the name of the fruit that we were searching on. So, when the user refreshed our application, they could get the same fruit list back based on their search. I suggest you guys to revisit that code as well. But just so to make the concept more deeper and more understandable, I changed that example to match to our Pokemon list. So in this list, if you see, we have an ability. Let me make this smaller if I can to uh, see a Pokemon's evolution. So if I click on Bulbasaur, so this everything is clickable. You see Bulbasaur goes to Ivysaur to Venusaur. So it's like their uh, evolutions. If you guys know Pokemon games, uh, if you don't know, then it's still okay. You just remember that you're displaying some information of a Pokemon when you click on it. So if I click on Venusaur, let's say Charmander, I'm showing some information about Charmander, and our Poke API guys provide another API called Poke API/evolutions and chain to display the information that we see on the right side of your screen. Now this is good. Now we are able to see information about, let's say, Caterpie and display it. In many scenarios, you might want to not start with an empty right-hand screen that we had. We did not have the screen when we first loaded our application, but instead, if the user hasn't clicked on anything, you might want to display the previously clicked item. To do that, you can do is when user clicks on an item, you can save it in local storage. So let's look at it here. In our table, uh, we have a click on each table item, handle Pokemon click in our code. And when you go to this code, we are saving the Pokemon in local storage and then calling an API to get the evolution details. So the benefit of it is when we save it in the local storage, uh, this details, we have an ability to before user clicks on anything, display some information when they first come into the application. This is very similar to what we had done with our fruit list. So you will have another example of how you can use local storage or session storage to save some information and display. So this API call failed, but that's okay. So if I refresh my page and be slow about it, I'm displaying the information of Caterpie even before clicking on it. So let's say if I clicked on Charmander, and now if I just refresh my page, I'm seeing this information about Charmander because when we click, we saved our uh, detail on the local storage. And when we first load our application, we are getting that local storage information, which is previously saved Pokemon, and then calling that second API to get the right side of information. By doing so, we start with some information as well as we are able to remember the user actions. Uh, so this is the another topic where you can, along with the other stuff, you can remember the previous searches of this can be applicable to anything, right? So I'm right now remembering Pokemon name for displaying the evolution chain. But let's say if you're on a Amazon and you're searching for, let's say, new shoes, they could remember that new the thing that you had typed before. So when you come back to Amazon, you're able to display the previously saved item. So this is about the local storage and how do you verify that what was saved on local storage? Again, to repeat our concepts, we save it on, you go to the applications in our debugger console, applications, then ideally it would be like this. You click on local storage, then click on the URL, and you'll be able to see the selected Pokemon. So we have had, when we built some of the previous applications, we had saved input, search terms. These are coming from our previous applications. So local storage is something that will not go away even if you close your browser. But had I saved it on session storage, it would have gone. So I recommend you guys to read about local storage and session storage more. Refer back to our previous example of uh, how we were doing with the storages and with the sorry fruitless storages and how we were showing this information. So that's about the storage, storing user inputs, and that sort of concludes the four topics we wanted to cover for the day. Any questions on uh, again sorting, searching, sorting, or saving the information, etc. Again, I'll provide all the code that is there. The code is essentially two applications in one, and you guys would be able to sort of play with it and make your adjustments. But yeah, any questions? Anyone? The sec If you don't want to sort of go to the first app, I think this list is also sortable. So if you just follow the code in app2.js, once you clone this, you guys should be good. But yeah, I'm there to answer any questions you guys have.